So today we are going to discuss about display of numbers from 0 to 9 through one 7 segment display. 7 segment display is commonly we have seen in all the electronic gadgets. It is available. Suppose if we are using the lift, then in lift to display the floor from 0, 1, 2, 3 like this, or 7 segment display is there. Even in air condition we find that 7 segment display. So how to display the numbers through that 7 segment display, and how we will do the interfacing of 7 segment display with the microcontroller. What are the codes program required to display the numbers? All these we will see. First we will discuss about 7 segment display. So 7 segment display looks like this. So here basically these are 7 segments. This segment is named as A, B, C, D, E, F, G. So these are 7 segments, and with the 7 segment display there is also an 8th segment is also there, and that is one dot. This is one dot. So basically there is one LED for each segment. To display particular segment, suppose we want to make this segment glow on, then we have to make that LED on, then A will glow. If you want to glow the segment D, then you have to make the segment D LED on. So this 7 segment is available in the market in 2 forms. One is common cathode type, and second one is common anode type. Common anode type. So we will see this common cathode type. In common cathode, see, we know that in a LED, this is suppose one LED, there are 2 terminals. This is the positive terminal of LED, and this is the negative terminal. And negative terminal is also called as cathode. So in case of common cathode type of 7 segment display, all the cathodes of all of these segments will be joined together. They are all common. So I will take one example. You will see some 7 LEDs. One, two, three, 4, 5, 6, 7. These are the 7 LEDs for A, B, C, D, E, F, G, and one for dot. So we will write here, this is for dot, this is for G, H, E, D, C, B, and E. Now in case of common cathode type of 7 segment display, these are the cathode terminal of all the LEDs. They are joined together and commonly they are connected to ground. And in case of common anode type 7 segment display, all the anode terminals, these are the anode terminals, are joined together and connected to a common plus 5 volt. So we will discuss about common cathode type. So all the terminals are joined together and connected to ground. So if this terminal is connected to ground, to glow this LED, what we have to do? We have to forward bias this LED. To make it forward bias at the P terminal, we have to supply plus 5 volt, or we have to give binary 1 value. So in this case, this LED will be forward biased and light will emit from the LED, and we can see the LED is glowing. So now first we will find out what values are required over these A, B, C, D, E, F. This is F, G terminals. These terminals, what values, binary 0 or binary 1, are required to display numbers from 0 to 9. So here it is dot, G, F, then E, D, C, B, A, B, C, D, E, F, G. Okay, this is dot. So display, we want to display this is 0, this is A segment, B segment, C segment, D segment, E segment. Here there are 2 segments like this: A, B, C, D, E, F. And to display 0, G segment will remain off. So in that case, and A, B, C, D, E, F, all these segments will emit light. So we can see 0. And for display this, what hex code is required, that we will write in this column. So now since this is a common cathode, we are talking about common cathode, 7 segment display. So at the G terminal, we have to send binary 0, and at the remaining 1, 1, 1, 1, 1, 1, we have to send this value. And what we will do, we will make this dot off, and we can make this on also. This can also glow, or it can remain off. So what we have decided, that we will make this dot off. For that, we have to send 0 here. So this value we have to send to display 0. 0, 0, 1, 1, 1, 1, 1, 1. And hex code we will write for this. So this is 0, 0, 1, 1. So this is 6, and 1, 1, 1, 1 is F. So 6 F in hexadecimal is required to send the values over these segment for the display of 0. Now if we want to display 1 will be displayed like this. Segment B and segment C will on. So segment B is on and segment C is on. Remaining segments are off. Code for this is 0 0 0 0 0 A and 0 1 1 0 0 6 0 6 H is required to display 1. Now 2 we display like this. This is A, B, C is off, D, E, F is off, and this is G. So A, B, D is 1. A, B, D, E and G. E and G. They are all on and remaining segments are off. Yes. And the hex code is 8421. These four, 5, and this is 11, means B, H. Now to display 3, this is A, B, C, D. They are on. E, F off and G on. A, B, C, D on. 1, 1, 1, 1. Then 0, 0, 1, 0. So this is 4F. 4F is the code for 3. For 4, we display 4 like this. Okay. 4. This is 4. This. Okay. So this is B, C, D, E, this is F, and this is G. B and C are on. B, C, F, G. F, G. Remaining segments are off. So control word is 6, 6, 6, 6, H. For 5, A, C, D, F, G. A, C, D, F, G. A, C, D, F, G. So control word is 6 and 13. 13 means D. Then 6. So we will display 6 like this. In this way. So A, C, D, E, F, G. Only B is off. B is off, remaining segments are on. So this is 7 and this is 13. 7D, H. So 6, after this 7. We display 7 like this. So A, B, C are on. A, B, C are on, remaining segments are off. 0 and 7. For 7 it is 0, 7, H. For 8, all segments are on. A, B, C, D, E, F, G. All are on. 1, 1, 1, 1, 1, 1, 1, 0. 0 for dot. In all the display, we are making that dot off. So this is 7F. 7 9 we will display like this: A, B, C, D. E is off, F, G. Only E segment is off, remaining are on. E segment is off. All are on. So this is B, F. So for 9 it is B, F, H. So these are the code. These are the hex code which we have just found out for the display of numbers from 0 to 9. So somewhere I will write down these codes. Codes are 6F, 06, 5B, 4F, 66, 6D, 7D, then 07, 7F and BC. This is a last one is for 3C, not BC. This is that is 6C, 6F. This is 842 means 6. See 6F. 6F. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the 10 codes. So now what we will do, so we will connect these 7 segments, 8 segments basically, A, B, C, D, E, F, G and dot with our 8 pins of port 1. So suppose we will connect A segment to port 1 pin number 0, B at port 1 pin number 1, C at port 1 pin number 2, D port 1 pin number 3, E port 1 pin number 4, F port 1 pin number 5, G port 1 pin number 6 and dot port 1 pin number 7. So basically we are utilizing our port 1 to interface this 7 segment display with microcontroller 8051. Now in our program what we will do, first we will display 0 and it will remain displayed for some time, and after that we will display 1, then we will give some delay so that this 1 should be visualized for some duration. So like this we will display the numbers from 0 to 9, and after that 9 again 0 will start, again 0 to 9. So continuously numbers will be displayed with some delay. So basically we have to write our program in 3 sections. One section will be our main program, and whatever code we have just now calculated to display the numbers, these codes will be loaded in code memory. And from the code memory we will retrieve these codes. So we already discussed that if some data is there in the code memory and we want to retrieve that, then basically for that we have to use one instruction, move C A comma at the rate A plus dptr. So basically we are going to use this instruction in our main program, and finally to generate the delay in between the display of 2 numbers, we have to write our delay subroutine. the delay subroutine we will use same code which we discussed in last class. Okay, so now we will write our program from org 0000, so it is org 0000h. So here we will write our main program. This is our main program, and then code we will load at some location org 0050h. So here we will load the code and we will give the name of that code as code colon defined byte is the directive, and now we will write these numbers 6F06 5B 4F66, then 6D, then 7D 07 7F and 6F. And delay subroutine we will write at some another memory location, suppose that is 0070h. Here we will write delay subroutine. So same code we will use, whatever we discussed in previous class. Move R1 comma hash 02D, move R0 comma hash 250D, D, J and Z, R0 comma label B1, this is label B1, then D, J and Z, R1 comma label B2, this is our label B2, and in the last we will use RE, return instruction. Now we will write the main program. Since we are going to display 10 numbers, so we will use one register as a counter which will tell us that tell the controller that we have displayed all the 10 numbers, now repeat the display. So for that we will use one register. Already in the delay subroutine we have used R0 and R1, so here I will use some new register R2, and in this I will load 10D, because there are 10 numbers. So you can write here 10D or you can write here 0A hexadecimal. Whatever we want, we can mention that. Okay, 10D. Now after this, what I will do, I will bring the address of my first code in DPTR register, because we have to use DPTR register in one instruction. So the memory location of this first byte 6F is 0050, and this location is denoted by this label code. So I will write here move DPTR comma hash code. Now after this I will make my A register 0, move A comma hash 00h, because every time we are going to use this instruction move C A comma @ A plus DPTR. So this will calculate the memory location where these bytes are stored, and that's why for every calculation always make A accumulator 0. So after this I will write this instruction move C. C indicates our we are going to retrieve the data by this instruction from code memory A comma @ A plus DPTR. So So now with this instruction, our first code is in accumulator, A register. So in accumulator we have this value 6F. 6X means F means 0, 1, 1, 0 and 1, 1, 1, 1. And this value we will transfer to port 1. For this I will write instruction move P1, comma A. So whatever is there in accumulator, it will be transferred to port 1. So in port 1 now this value will be transferred. This value means here you will get 0, 1, 1, 0, 0, 1, 1, 0 and 1, 1, 1, 1, 1, 1, 1, 1. With this what will happen? 1, 1, 1, 1, A, B, C, D, they will go A, B, C, D. They will go and 0, 1, 1, 0, 0, 1, 1, 0. So this will make G and F also glow. G and F. G and F. In this case 6F 8 or 2. So we want to display 0. 0 means this is 0 means A, B, C, D, E, F. They must glow. So A, B, C, D, only G will be off. Okay, G will be off. So G should be, this is G. And remaining will glow. Okay, this actually the code is 0011. Right? 3, this is 3. This is 3F. So it is 0 and 1. This value here we will write 3F. So this 3F will be transferred to port 1. This is a 3F binary value. This will make G off and dot off. So G is off and dot is off. So 0 will be displayed. After display of 0, we will just send the program to this delay subroutine so that this 0 should remain visible for some time. So that's why here we will write instruction L call delay. So delay is a label. So program will come to this particular label. These set of instructions will be executed and it will generate some delay. In the last RET instruction, it will return back program to the main program after L call. Now after L call, now what we will do? We have displayed first number 0. Now we have to display second number. So we have to bring the address of the second number. Address of code of the second number in DPTR register. For that we will write instruction INC DPTR, because now previously for the first byte the value of DPTR was 0050. Now we have increased the value of DPTR by 1, so it will become 0051. At 0051, 06 is loaded, which is required to display next number. Now we will check whether we have displayed all the numbers or not. For that what we will do, we will decrease this register by 1. If it is not 0, then we will repeat the process. So D, J, N, Z, R2 and back. If R2 is not 0, go back and here we will come back. So in A, by this time in A we are having value 3F. Now this 0 will be loaded in A. So A will become 00. Why we have made this A00? Because in the next instruction we are calculating the address of our second byte by adding the value of A with DPTR. With INC DPTR, the value of DPTR is 0051. So if we will not reset this to 00, then what will happen? This value which was in A, that will be added with this. CF will be added with this and some address will be generated. At that address, we are not having these codes. That's why we have reset this A to 0, 0. And now second number will come in A, that will be transferred to port 1, again go to L core. So this delay will be generated, then again come back to the main program, INC DPTR. This will bring the address of our third byte to display 2. So that address will be in DPTR, then decrease the R2. So in this way this loop will run. Finally when the R2 will become 0, this will indicate us that all the numbers from 0 to 9 have been displayed. So after that only we will come to this place. And now once we have come out from the loop, means once we have displayed numbers from 0 to 9, now again we have to continue this process. So for this, I will write an instruction as JMP repeat. And I will go to here, repeat. Because by DGNZ R2, the value of R2 has become 0. Again we have to reload R2 with 10. So that again we have to display the numbers from 0 to 9. So in this way the whole code will repeat once again. So this is the whole code which is required to display the numbers from 0 to 9 with some delay. The last we will write end. Now as an assignment, what you do, just now I will also display this code with the interfacing of 7 segment with the microcontroller with the help of MCU 8051 software. And now as an assignment what you do, you develop the hexadecimal code, these type of code by these codes for common anode type 7 segment display. What will be the code for, if suppose in place of common cathode, if we have taken common anode type display, then what should be the code for displaying of numbers from 0 to 9? And after finding out those codes, simply replace those codes here in your program and run the program and select common anode type 7 segment display and numbers will be displayed. Okay, so this is the code. Just now we discussed. So I have written this code on MCU IDE. So here org0000 and now our main program starts. So here I have taken the label start. Okay, in discussion we have written the label repeat, no problem. You can write repeat or start whatever you want. The only thing is in the and also as jump start, I have written start, no problem. Then move R2, 0A, move DPTR, code. So this is with this label code, the address will come. So here code, this is org0050 and here we have written the code to display of numbers for common cathode LED 7 segment. Then this is a delay program. This is a delay program, right? This is our main program. So move C A comma at the rate AP A plus DPTR, then move P1 comma A, L call delay, INC DPTR, DGNZ R2 back and S start. So this is the code. Now we will interface port 1 with our 7 segments of LED. So for this you will go to virtual hardware. There is option virtual hardware, just click this and there you will find LED display. Second option LED display. Click this. Now it is not coming now. You focus just only this now. Okay, so now this is the 7 segment display. So you will find this is A, B, C, D, E, F, G, and this is dot. This is dot. So what we can do? We can select common cathode or common anode here. So this is option. There is one this icon. you just left side of on, where on is written, left side of this you click this. Now first option is common electrode, and by default common anode is selected. So you can select common cathode. Now this is our A segment. A segment is connected to port 1 pin number 0. So this is connected here with the port. So I will select port 1 pin number 0. Then B segment is connected to port 1 pin number 1. Then C segment is connected to port 1 pin number 2. D, this is D segment is connected to port 1 pin number 3. E segment is connected to, this is for E segment selection, port 1 pin number 4. F segment for selection, F segment, this option is there, port 1 pin number 5. This is G. For G, here you have to select port 1 pin number 6. And this is for dot. See, for this dot, it has to be selected through this option. So port 1 pin number 7. So by default, all the ports of the microcontroller generates binary 1, high value. That's why, since high value binary 1 is connected to the anode terminal of all the segments, cathode are already ground. That's why all the segments are in on condition. All are glowing now. Right? Now when we will run our program, then 1, 0, 1, 2, 3 up to 9 things will be displayed and things will be repeated after that. So I will now run the program. For running the program, simply you click this option where continuous run will be there, and you just see here. Port, why it is not running, you have to check. This is on, off, on, and we have selected common cathode type, okay, and port 1, this is also okay. Right, so and if you need run the program, why it is not running? This is yes, we have not started the simulation. Now start. Yes, simulation was not started, that's why it was not running. So now is 2, this is 3, 4, 5, 6, 7, 8, 9. Now 0 will repeat. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So this will repeat. Now in this program, what I will do, I will just stop this. What I will do, I will change the delay. Suppose in R1 register we are having 2. If I, in place of 2, if I put 1, let us see what will happen. And again, so to run the program you have to click this button, start simulator. Right, now I will again start with this. Now it is fast, display is fast. 6, 7, 8, 9, 0, 1. So like this now, because see what we did in R1, we reduce the value of R1 from 2 to 1. So with this what will happen? Previously this loop was running 2 times, because here we have written dgz R1, D2. So that loop was running twice, but now only once that loop will run. So if the loop will run for less number of times, then controller will require less time to execute those instructions. That's why delay has been reduced. And if we remove R1 register, then let us see what will happen. So for this we have to stop this, and I will remove this R1 register. Only R0 register is there. Right. Now I have made this change. Now let us see what will happen. Now again I will run the program. Now let us see. Now it is fast. 6, 7, 8, 9, 0. And suppose now what I will do, I will reduce this value 250. From 250 I will make it 100. So now what will happen? In R0 it is 100, dgz R0. So now this loop will run only 100 times. After 100 times value of R0 will become 0 and program will come out from the loop. So now delay will be further reduced. So in this case, let us see. We will run this program first. See, now it is very fast. Right? And we will further reduce this from 100 to, we will bring it to 50. Now let us see. Run this. Now you see. Now, however, even we are unable to see few numbers. That was fast it is. That was fast it is. Because the delay will be in microseconds, very small delay. And in this way you can just check this program in your MCU 8051 and you find out the code for common anode. Then you replace the code for common anode from this program and select the common anode type 7 segment display. Right? Then you run your program. Then you check whether you are getting the result or not. You just consider this as your one assignment.